Question 4 is a ladder question. As you can see there, again, basic diagrams put out for you, and a load of information is given to you. So, as usual, out comes my copy of the diagram, and start putting on what I know there. So, I know that I have got a load of 4W is placed at point C. That's 4W, so I can resolve that into that being theta, 4W cos theta, 4W sine theta, and that's at distance 3a. I've also got the mass of the ladder, or the weight of the ladder, which is W. I haven't got room to put a triangle in there, but I think we can work out that that's going to be a vertical component parallel to perpendicular ladder is going to be W cos theta, and parallel will be W sine theta. I've got a reaction at A, and it tells me that the ground's rough, so the ladder will be wanting to move out that way, so I have got friction holding it in there, as it's all in limiting equilibrium. Have a smooth wall there, so there's no friction at the top, but there is a reaction at B, and I can split that down, with that being theta, so that's RB sine theta acting that way. Anything else I need? I've got tan theta equals 2, so I can quickly sketch that as a triangle. That is 2 and 1, so that's going to be root 5. That's theta. So sine theta equals 2 over root 5, cos theta equals 1 over root 5. So there's no need to actually find out what theta is there. Okay, I think that's put everything in I need. Just make sure that's at 2a. And as you can see, the diagram is getting quite crowded, even though it's quite large, but I need it so I can work through my calculations. So I'm going to start with the whole ladder, and I'm going to resolve vertically as positive. This is sort of preparatory almost, just sort of getting some equations together. And what have I got? I've got RA minus W minus 4W. It's in equilibrium, that equals 0. RA equals 5W. I'll call that equation 1, because I'll probably be coming back to that one. Let's resolve horizontally as positive, again for the whole ladder. And friction minus RB equals 0. So friction equals RB. That can be equation 2. I'll come back to that one, I expect. Right, so next thing I'm going to do is take moments. Clearly defining where I'm taking moments about. I'm taking moments about A, and I'm going to take it in a clockwise direction. So I have W cos theta times by 2A. And I've got, this is all positive because it's clockwise moment, plus I've got 4W cos theta, and that's times by 3A. And finally, I've got minus, there's no moment there, so I've finally got RB, and that's going to be sine theta times by 4A, and that lot's going to equal 0. I can get rid of the A's, I can tidy things up. That gives me 2W cos theta plus 12W cos theta, so I've got 14W cos theta minus 4RB sine theta, and that equals 0. So RB equals 14 W cos theta all over 4 sine theta. I know what sine theta and cos theta are, so I worked out in the preliminary workings, so I can plug those into that equation, and I get RB equals 7W over 4. Now from equation 2, I know that is equal to the friction. So from friction equals 7W over 4. And then from 1, I know that the reaction is 5W. Now, that's friction. Friction equals mu R. So we know from 1 that R is 5W. So 7W over 4 equals mu times 5W. W's cancel out. Mu equals 7 over 4 all over 5, which equals 7 over 20, which equals 0.35, which is what we're after. Question 4, part B. In this question, we're still working with the same basic diagram as shown there, but there's a load more information that's been given to us. Some things have been removed, other things have been added. So basically, we're going to start again from scratch with the diagram. And what have we got? We know that mu equals 0.35, so that's staying the same. And what have I got? I've got a load of 4W is being applied at B, so I can resolve that. And that load has been moved from C. I've still uniform ladder, and so I've got W at the midpoint. I have got reaction at A, but I've also got an added KW at A. Friction is still going to be acting inwards. And I've got a reaction at B. I can just split up there if I need to. And that is theta. And I think that pretty much covers everything. So the first thing we're going to look at is resolving vertically. And I get RA minus W minus 4W minus KW equals 0. So RA equals 5W plus KW equals W5 plus K. So that's a reaction at A. I now know mu is the same, so friction equals mu W times 5 plus K, so that is 0.35 W 5 plus K. And at that limiting equilibrium, if I resolve horizontally, again I've got friction minus RB equals 0, and so friction equals RB. And so up to limiting equilibrium, reaction at B must be less than or equal to friction max. Bearing in mind that friction obviously at any particular point when it's in equilibrium equals reaction, but reaction must be less than the maximum value of friction. Right, so I want to find out what RB is, so I'm going to take moments about A, and I'm going to take those as clockwise as positive. So what have I got? I've got 4w cos theta times by 4a plus w cos theta times by 2a, and just run off a line there, but minus rb sine theta times by 4a, and that must equal 0. So let's combine a few of these things. What have I got? I've got 16w cos theta plus 2w cos theta, so I've got 18w cos theta. And also the other thing is I can cancel all the a's out because there's an a in each term. So 18w cos theta minus 4rb sine theta equals 0. rb equals 18w cos theta over 4 sine theta. Now I know what cos theta is because we've got it up here. I know what sine theta is, they're just numbers, so I can work all that lot out. rb equals 9w over 4. Okay, so I can now go back to this equation here, and I can say 9w over 4 is less than or equal to the maximum friction, which is 0.35 5 plus kw. So I can cancel out with w's. 9 over 4 is less than or equal to 0.35 5 plus k. 5 plus k is greater than or equal to 45 over 7. 9 over 4 divided by 0.35. And so k is greater than or equal to 10 over 7.